All right, let's dive into one of the biggest and maybe one of the quietest upgrades happening to the internet right now. It's all about getting our digital world ready for a totally new kind of challenge. Let's get into it.
When you think about it, so much of what we do online, from banking to sending a private message to buying something, it's all protected by this hidden layer of digital locks. And those locks are really just very, very difficult math problems. Our entire digital life is basically built on the fact that for today's computers, solving those problems is pretty much impossible.
And that is the big question. What if a totally new type of machine, a quantum computer, becomes powerful enough to solve those problems in a snap, to just break the locks that keep our digital world safe? What do we do then?
Well, to understand the solution, we first have to get a really clear picture of the problem. So let's take a look at the hidden threat that's pushing this massive global upgrade forward.
Okay, so here's the core of it. The digital locks we rely on every day are safe simply because the math behind them is way too hard for the computers we have now. I mean, it would take them thousands of years to crack the code. But a future quantum computer? It could theoretically pick that same lock in just a few minutes. And that is the vulnerability we need to fix.
So now that we see the threat, let's talk about the defense. What exactly is this post-quantum security everyone's talking about?
In the simplest terms, it's a huge, proactive upgrade. We're developing and rolling out brand new types of encryption, new digital locks that are built from the very beginning to be tough enough to resist attacks from both the computers we use today and the powerful quantum computers of tomorrow. We're basically switching to safer math problems.
Now, this is really important because it clears up a huge misconception. This is not quantum encryption. You don't need some sci-fi quantum machine to use it or to be protected by it. Post-quantum security is all about new software, new algorithms that are made to run on the exact same laptop, phone, and servers you're using right now.
So you might be thinking, okay, but if these super powerful quantum computers don't even exist yet, why is everyone in such a rush? Well, that brings us to what is maybe one of the most urgent security problems out there today.
It's a strategy called Harvest Now, Decrypt Later. And it's as sneaky as it sounds. Here's how it works. Right now, attackers can steal massive files of encrypted data that's perfectly safe today. Then they just store it. They hold on to it for years, just waiting for the day a quantum computer is finally built that can crack the code and unlock every single one of those secrets.
And we're not just talking about random data here. Think about information that needs to stay secret for decades. This is government and defense secrets, your private healthcare records, a company's most valuable intellectual property, and, yeah, even your private messages. The real threat is to the long-term privacy of our most sensitive information.
So how do you even build a lock that can resist a key that hasn't been invented yet? Let's look at the new security standards that are designed to do exactly that. There's been this huge global effort, led by experts at NIST in the US, to create new standards based on this safer math. And they basically do two main jobs. The first is to create a secure connection. You can think of it like a secret digital handshake to exchange data safely. And the second job is to verify identity, acting like a forgery-proof digital signature, so you can prove you are who you say you are online. Now, this is not just some theory happening in a research lab. This upgrade is already being quietly built into the technology you use every single day. Let's take a look at where. You know that little padlock icon in your web browser? Well, every single time you connect to a secure website, your browser and that site do a quick, secret handshake to keep your data safe. That handshake is one of the very first things being upgraded with post-quantum security, which helps protect a massive chunk of all internet traffic. It's also showing up to protect your private conversations. Major messaging apps are already jumping on this. Apple is rolling out a new post-quantum protocol for iMessage, and Signal has already upgraded its system. It's happening right now to make sure your private messages stay private for decades.
And it goes even deeper than that. This upgrade is happening all across the digital world. It's being built into the VPNs that businesses depend on, the systems that check if your software updates are real and not a virus, and the digital certificates that are the foundation of trust and identity online. So how do you manage a transition that is this huge, this fundamental, without accidentally breaking the internet? Well, the answer is to use a very smart, very cautious strategy. It's called hybrid migration. Instead of just flipping a switch and hoping for the best, companies are running both at the same time, the old trusted encryption and the new post-quantum encryption, together. That way, your connection stays secure, even if there's some undiscovered problem with one of the methods.
Think of it just like this. You're installing a brand new, super high-tech lock on your front door, but you decide to keep the old, reliable deadbolt for a while too. You get the best of both worlds, the new layer of protection plus the security you already trust. It's a safety net that makes the whole transition much, much safer.
And make no mistake, this isn't some future plan. This era has already started. In 2024, NIST officially finalized its first set of primary post-quantum standards. That wasn't a drill, that was basically the starting gun for the entire tech world to begin this migration.
So, the next time you open your browser or send a message, just remember this. Post-quantum security isn't science fiction. It is the real, silent, and absolutely essential upgrade that's happening right now behind the scenes to rebuild the very foundations of our digital world and to keep it safe for all of us for generations to come.